Hello, everybody. I want to thank Jamari for the introduction. My name is Roy. I'm going to see how this works. Yeah. OK, perfect. So I'm going to introduce today Previse AI. We're a startup. We're building machine learning algorithms for the construction industry. This is a background about me. I want to start off by introducing the construction industry. It's one of the largest industries with an annual spending of around $12 trillion. It's going to grow up to $13.4 trillion in the next 5 years. The growth rate is around 30% annually for the next 5 years, compared to 15% for the previous 5 years. So it's really growing. People are adding more money into this business. And there's a lot of problems with the construction industry. I'm going to read this because I like it. Global engineering and construction sector holds the dual distinctions of being one of the one of the world's largest industries, yet one of its least efficient, and that's true. I come from a construction background. I've been doing software engineering, computer simulation and modeling, data science, machine learning for the construction industry with one of the largest contractors in the world for the past 25 years, and I've seen this firsthand. It's one of the least digitized industries. It has a very low productivity growth. The global average for productivity growth is around 2.8% per year. For the construction industry, it's around 1%, and that's really low. And this is mind-numbing. 98% of capital projects globally incur either cost overruns or schedule delays or both. Coming to machine learning and construction, there's a lot of work being done in machine learning in general, but very little in the construction industry. Some of the work being done is about basic analytics. Some of the work being done is for safety, which is very important. Visualization, predicting if this is a person or an object, controlling machines so we don't hit anybody, we don't kill anybody, we don't injure anybody on site, which is really important. But still, nobody is doing anything with machine learning for productivity. Very little is being done for predictive maintenance, none for performance optimization. And this is what we're trying to do. Let me just mention this. The investment in the construction tech has grown a lot over the past few years. We can see on the right, there's a chart. It's expected to have around $920 million invested in technology in the past, well, predicted to have been invested in the past 12 months. We'll see the reports coming out soon. But the thing is, there's a lot of investment going in right now, but none of it is in machine learning for performance. So this is what we're proposing to do. Site Assist, our product from Previse, it's the construction industry first AI-enabled equipment performance prediction and optimization solution. What are we doing? We're building 2 machine learning models. One of them is going to be an equipment performance prediction model, and one of them is an asset predictive maintenance model. Asset predictive maintenance is interesting. There are some players in the field, but very, very few in the construction industry. And in construction, if a machine fails on site, it's a big thing. First, you have to either fix it on site or bring it back to the yard. It's not only that, it's going to have a downtime that affects the immediate activity, and then it's going to have a knock-on effect on all the activities related to this activity. So it's a big thing in a construction project. Equipment performance, nobody's doing machine learning for equipment performance. So the equipment performance prediction model, it's going to help project managers, estimators, engineers, foremen, whoever is involved in a project, even owners, which is very important for owners, to predict and evaluate equipment performance on construction sites, both during estimation and execution. And estimation is going to help us estimate the number of equipment required, build a proper price estimate. We're not underestimating, we're not overestimating. If we are underestimating, we're going to get the project, but we're going to fail. If we overestimate, we're not going to get the project because we're going to price too high. So we're going to help price properly. When we get the project, we're going to execute it right. In planning and execution of a project, if we put too many equipment on a project, we're spending too much money, we're finishing ahead of time, but that's a loss of money. If we put too little equipment, we're going to have schedule overruns, and we're going to have cost overruns. We don't want any of those two. For asset predictive maintenance, I'm rushing here because I only have 10 minutes. So, asset predictive maintenance is really important for construction. Very few people are doing asset predictive maintenance. We have a proof of concept that's really doing well. These are some of the typical learning data sources. We're getting data from telematics, IVMS equipment. We're getting data from asset management systems. Excuse me. We're getting data from ERP systems in the construction industry. And this data can be both offline and online. So it depends on the project we're working with, the client we're working with, the situation we're working with, the type of data we're collecting. Some of this data might be manually filled at one point. In construction, you'd expect to have a lot of data cleaning. Some of the data collected has data gaps, some of the data collected might be wrong, so there's a cleaning effort in the data. I'm going to dive into one of the models we've built. We've taken the equipment performance prediction model and tuned it for truck speed prediction. By truck speed prediction, I mean predicting what the speed of a construction truck is going to be on a certain site doing a certain operation with a specific workload. We've built an artificial neural network. The features we collect from construction jobs. There's a lot of features we collect and we put into the model. Our outputs are two. What's the speed of the truck empty? What's the speed of the truck loaded for that specific operation on that job carrying that workload? Let me explain why it's important very quickly. When we're trying to estimate how much a project will cost, when we're trying to plan the execution of a certain operation, let's take an earth-moving operation for a big project. When we're doing an oil and gas project or an infrastructure project or a road project, earthworks or earth-moving is very important. It's very large. When we're trying to estimate the amount of time and the number of equipment required for an earth-moving job, what goes into earth-moving is we want to calculate the number of trucks required. Why? Because we need to understand how many 1 minute? Oh my God. Okay. Very quickly. Number of trucks is very important. To calculate the number of trucks, we need to understand the cycle time of a truck. The cycle time has 4 components: load, dump, move the material, come back empty. Moving the material and coming back empty is a combination of speed and distance. That average speed is a variable that everybody gets wrong when they're trying to assume. When they make an assumption about speed, they miss it. Not because they don't understand engineering or they don't understand construction, but there are too many variables involved that they're not aware of. What happens when you miss that variable is you calculate the cycle time wrong. When you get the cycle time wrong, most probably you're underestimating the equipment requirement for a project. So you're going to put too little equipment on a certain operation. When you put too little equipment on a certain operation, you're going to have a schedule overrun and cost overrun for sure, due to the schedule overrun and overheads. What we try to do is we try to predict the exact or a very accurate value for that speed so we can get a proper cycle time and we can do a better job predicting the total equipment requirement, the total cost, and plan a proper execution of the operation. Very quickly, we've done this. We've created a model that produces 94.1% accuracy based on a data set of around 1 million records. We cleaned that 1 million record data set and we got around 400,000 records of actually usable data. That was very interesting to see that that much data was not actually usable. Comparing the traditional to the ML approach, we can save money and we can save time on projects and we can come in with a better estimate and better execution. This is only one type of models we're building. And this, yes, done? Oh, yeah, okay. So I have a case study. I just want to mention that we were able to save $21 million on a $120 million earth-moving operation with 3 weeks of work, which is really interesting. And that was the start of the work we're doing. We've applied this on 6 mega projects right now, and we're looking to expand on this. Thank you so much.